Okay, hi guys. So here's the phase 6 video notes. And okay, so I'm about to write down the two limit processes that we have for finding the derivative of a function. And then next lesson, you'll see some shortcuts. So in the future, when we find the derivative of a function, we're not going to have to use a limit. We're going to be able to use some other rules that allow us to do it faster. Okay, but here's just a little review of this one. So right here is the limit process for finding a formula that will give you the derivative of a function at any point, okay? So here we've got this situation. So you saw this earlier in an intro video that I asked you to watch. So here's x plus h, okay? H is just some number like, some positive number. So x plus h is further to the right of x. And if you do, so here's the secant line, all right, that goes through these 2 points that correspond to x and x plus h. But then the idea, guys, is that as h approaches 0, all right, so h is the difference between these 2 points. And as h approaches 0, these 2 numbers get closer and closer to each other, all right? So instead of the secant being from here to here, the secant is here and here and here and here and here. The endpoints of the secant are just getting closer together, and then eventually you have the tangent line. And it is the slope of the tangent line which is the derivative. Now remember, the secant slope, if you put the points like in a table like this, and then you do y minus y over x minus x, you have this. So this is the secant slope, all right? And then, so here I have written the secant slope. To get the tangent slope, which is the derivative, you want these 2 x values to get closer and closer. So you want this right x, oh gosh, why is it not focusing? All right, you want this right x value to approach the left x value, so h approaches 0. So the limit as h approaches 0, all right, so that's f prime of x. So this formula will give you the derivative of a function at any point you want. Okay, now here's the new one. This one is the limit process for finding the derivative of a function at a specific point. Okay, so instead of this picture, I'm going to flip over. All right, looks the same, but here, okay, here we have this number c. And then here we have this number x, which we can assume, let's just assume it's to the right of c. C is a specific number, x means like any number to the right of it. And okay, so here's the secant. If I want the secant to become the tangent, I need this number x to approach this number c. So x approaches c, and then the secant becomes the tangent. And guys, it's the slope of this tangent line, which is f prime of c, okay? And c stands for a specific number, whereas x stands for like any number. All right, now the secant slope, all right, if the x value is c, the y value is f of c, x value x, y value f of x, and then you do y minus y over x minus x, and so here you have the secant slope, all right? So this time the secant slope is this. Now guys, what kind of limit do we need to take for this in order for the secant slope to become the tangent slope? What needs to approach what in order for this secant to become this tangent? This x needs to approach c. This number x needs to get closer and closer to that number c. So this is the limit as x approaches c, that's going to give you f prime of c. F prime of c. Okay, and that's the one that we're going to use. So let's do this first example. Give 2 phrases that are synonymous with the slope of the tangent line to the graph of the function at a given point. And then we're going to use a limit process to find the slope of the tangent line to the graph at x equals 3. So for part A, so slope of the tangent line, that's the same as the derivative. And then they are both the same as the instantaneous rate of change. Okay, now for part B, use a limit process to find the slope of the tangent line of the graph of f at x equals 3. So we're finding the slope of the tangent line. So we want the derivative. I mean, you could first find the derivative at any point using this formula and then plugging 3 into it. Or you could use this formula and just get the answer right away. So we're going to use this formula this time. So either formula would work, actually, but this formula will give you the answer immediately, whereas this formula would give you another formula that you would then plug 3 into. All right, so we'll use that one. So f prime of c is what we're looking, or f prime of 3. F prime of 3 is what we're looking for. So that's going to be the limit as x approaches 3. Okay, so here c is 3. And then it's going to be f of x minus f of 3 all over x minus 3. So this is the limit as x approaches 3. All right, f of x is 3x squared minus x minus f of 3. Oh, shoot. So that'd be 3 times 3 times 3, which is 27, right? And then 27 minus 3 is 24. I hope I'm right. All right, try to direct substitute. You can't. It makes the denominator 0. So I've got to go limit as x approaches 3, leave a blank, and then do an aside. So I want to take this. So this is 3x squared minus x minus 24 all over x minus 3. So I want the x minus 3 to cancel. So guys, up here, all right, so this is 3x squared minus 24. I need to split up negative 1x into two numbers that multiply to make 3 times negative 24 and add to make 1. Right, so I'm using a calculator. All right, 3 times negative 24. Oh, shoot, what am I doing? 3 times negative 24 is negative 72. Oh, 8 and 9. Okay, so it would be negative 9, negative 9x plus 8x. Okay, so that's going to be equal to, all right, so I'm going to factor out a 3x. And when I do that, I'm left with x minus 3. I'll factor out an 8. X minus 3. Oh, good. All over x minus 3. Okay, this is good. So this is 3x plus 8, x minus 3 over x minus 3, and that's what we wanted to cancel. All right, now I can go back up here. Now you can direct substitute. 9 plus 8, so we get therefore f prime of 3 is 17. Okay. All right, let's do another one with a fraction. Okay, use two, all right, so give two phrases that are synonymous with the instantaneous rate of change of a function at a given point. Our instantaneous rate of change, same as the derivative, and then this is the same as the slope of tangent line. Okay. Oh, we want negative 3 this time. So f prime of negative 3 is going to be the limit as x approaches negative 3 of f of x minus f of negative 3 all over x plus 3, because it's x minus negative 3. X minus negative 3. So this is the limit as x approaches negative 3 of 5 over x plus 1 minus 5 over, okay, so if I plug a negative 3 in here, I'm going to get negative 2. Negative 2 all over x plus 3. But guys, this actually, this is a limit as x approaches negative 3, 5 over x plus 1 plus 5 over 2 all over x plus 3. Because this is you're subtracting a negative here. If a fraction is negative, the negative can go on the top, on the bottom, or right out front. Okay, either way, you're going to have a double negative, which is a positive. Can we direct substitute? No, we can't. So this is the limit as x approaches negative 3. I'm leaving a blank, and I'm doing an aside. All right, so I've got 5 over x plus 1 plus 5 over 2 all over x plus 3. I'll put it over 1 because I'm going to have to keep change flip eventually. And then, so the least common denominator, I need a factor of 2 and a factor of x plus 1. So I'm going to multiply this one by x plus 1. I've got to multiply that one by 2. We did that a lot last year for this purpose, because I knew we were going to have to do this. Okay, and now in the top, I'm going to have 10 plus 5x plus 5, I distributed, over 2 x plus 1 over x plus 3 over 1. All right, now I'm going to keep the top. I'll combine like terms here. I'm keeping the top, so this is 5x plus 15. Change, flip. Okay. 5x plus 15 all over 2, x plus 1 plus 3. Okay, I need that x plus 3 to cancel. So is there anything you can take out of the top? Yep, you could take a 5 out. You could have done that earlier if you saw it. 2, x plus 1, x plus 3. So the x plus 3's cancel. And then I go back up here. 5 over 2x plus 1. And then I can direct substitute. So this is 5 over 2, negative 3 plus 1. So that's 5 over negative 4. So therefore, f prime of negative 3 is negative 5/4. So guys, when you use this formula, you end up getting another formula. Darn it, I hate when it gets blurry. Okay, when you use this formula, you end up getting another formula that will allow you to find the derivative of a function at any point, so at any number you plug into it. When you use this formula, you end up getting a number, okay? So you want to use this formula if they're asking for the derivative at a specific number, this formula if they're asking for just the derivative, which implies the derivative at any point. Alrighty guys, I'll talk to you soon.